Hello, welcome to IBCC channel. In this video, we were talking about the redistributing routes into the OSPF. So first question is, why need to redistribute the route into the OSPF? To answer this question, let's take a look at this diagram. In this diagram, there are three routers. Router 1 and router 2 run the OSPF. So router 2 know all the OSPF routes of router 1. However, between the router 1 and the router 3, they only run the static routes. So in the router 3, their network is 192.168.1.0/24. So R1, router 1, have a static route pointing this network. However, R2 do not know this static routes because R2 only knows OSPF routes. The static routes is not OSPF routes, so R2 no way to know it in this setup. So in order to R2 knows this network 192.168.1.0, there is a way called the redistribute. That is R1 put this static routes into the OSPF routing process, right? Then since the static routes was put into the OSPF routing process, then if this routing information can be propagated to the R2. So at that moment, R2 will know this. That is why we need the redistribute. Okay, next, redistributing the routes into the OSPF. Right? Redistributing routes into the OSPF from other routing protocol or from static will cause the route to become the OSPF external routes. So external routes fall under two categories. One is external type 1, also called E1. Another is external type 2, also called E2. The difference between the two is in the way the cost of the routes being calculated. The cost of R2 routes is always external routes, in respective the interior cost of which the routes. E1 cost is the addition of the external cost and the internal cost used to reach the routes. The E1 routes is always preferred over E2 routes for the same distance. So that means when redistributed routes into the OSPF, the OSPF will generate the external routes. So external routes, the two types of external routes, E1 and E2. E1 is always preferred over E2 for the same distance. By the way, in the OSPF, there is a intra routes, there is inter routes, there is external routes, and now has the NS routes. So here list the preference. So intra routes O is preferred over to the inter-area routes. Inter-area routes is preferred over E1 routes. E1 is better than E2. E2 routes is preferred over NS1 routes. NS1 routes is preferred over NS2 for the same distance. So how to do the OSPF in the Cisco router? The below is a command. So under the router OSPF process ID, so the command is distribute protocol. Distribute protocol ID. Then you can give the metric and also give the metric type. Here the metric type can be the E1 or E2. Then next you can use the route map to control which routes can be distributed into the OSPF. The last parameter called the subnet. That's the important subnet for the OSPF. So if the subnet keyword is not used, then only routes that are not subnetted will be redistributed. For the OSPF, the world, most routes is subnetted, so you must use a subnet keyword. Okay, so let's go to the lab. I will show you the configurations. In the lab configurations, we will show you how can redistribute the static routes into the OSPF. Also, will show you how can use a route map to control which routes can be redistributed. So in this lab, let's take a look at here. So we will do the redistribute on this route ACC A-1. ACC A-1 have the two static routes pointing to the CXR1 here. So one static route pointing to the 30.0.4.0/24. Another static route pointing to the 30.0.5.0/24. So in order to propagate this static routes into all the OSPF domain, include area 1, area 60, area 70, area 70. So we need to do the redistribute these static routes into this ACC A-1's OSPF. So let's do it now. So show IP route. Show IP route. You see the last two route is two static routes, right? So you do the show one, include IP route. You see here there's two static routes. So these static routes, you can check these two static routes is in the OSPF domain or not. You can just log into the many way to check this. One easy way is just go to a next OSPF enabled router. Let's see, for this case, we can go to the AGGA. Go here. And just show IP route to the 30.0.4.0. So now in table. So that means currently this OSPF know nothing about this static routes. Same thing, check another routes here. Now in table. So that means it's not in the OSPF table yet. So another way to check the static routes in the OSPF the domain or not, you can just check the OSPF database. So you can back to the same route to check. So show IP OSPF database. So for this case, you want to check the external database. So you do the external. You put the route here, 30.0.4.0. So now in database also, you can check another one, 5.0, now in database. Okay, so it's now in database. Let's do the redistribute. This time we just redistribute two static routes same time into the OSPF. Okay, so first check what the OSPF config. Okay, so let's go to the OSPF config. Do the redistribute. Redistribute what? Redistribute static. The metric, we just use a default metric. And don't forget one thing, just we also not control which route to redistribute. So we just use subnets, this keyword here, subnets. Okay, enter. So show run SRO. Take a look what do we configure. Okay, we configure redistribute static subnet under the OSPF process. Okay, let's see is work or not. To check this, let's go to the next router, OSPF enable router, AGG-A here. Just do the same thing, show IP route. Now you can see it, show IP route. You go to you see this route is inside the routing table. So you can see from output, you can see this type is E2, metric is 20. So this static route is redistributed into the OSPF as a default type E2, and the metric is 20. This metric 20 is always 20, regardless the internal cost. So what that means? So you see right now we check this router in the AGG-A. So his metric is 20. What happened? We check the same routes in the next routers. What is the metric here? Let's see. Let's go to the core one. Okay. Let's go to core one. Do the same. Show the same routes here. Show IP routes 30.0.5.0. Enter. See the metric is the same, no change. That is the character of the E2 routes. So E2 routes, the metric always stay external metric, won't change. So back to the AGG2. Let's take a look at another routes. So show IP routes 30.0.4.0. Let's see this one. How about this route? Okay, this route also into the OSPF already. Metric is 20 and extend E2. By the way, the distance for the OSPF is for Cisco route is 110. Yeah, right. So now we did the basic the redistribute. We redistribute static into the OSPF. Now what happened? If we just want only redistribute the 30.0.4.0 /24 this route into the OSPF. We don't want to redistribute the 30.0.5.0/24. Okay, so that's we need to use a route map to control this, right? Okay, let me show you how to do that. Okay, let's go to the ACC A-1 here to create a route map. To create a route map, we have to utilize a prefix list. Okay, let's do the prefix list first. So conf-t IP prefix list gives a name. Prefix list gives a name. What name is we call the pref one and permit gives a permit that's to the okay to the 30.0.4.0/24. So we do the exact match for this case. It's fine. Yeah, just do this. Then we create route map. So the route map gives a name. We just call the R-M-1. Then give the sequence number. Let's do the 10 to the permit. Okay, to the permit 10. Yeah, permit 10. Then we do the match. We match IP address prefix list. We already create the prefix list here. So pref one here. So we can do the set here, but for our case, we don't need to do the set. As long as match should be fine. So in the Cisco routers, route map at the end of the route map, there is an implicit deny, so I don't need to put the exactly deny sentence on the route map. So here should be fine. Let's go to the OSPF. Router OSPF 10. Usual set ROC. Take a look. Okay, let's modify this command. Do the IP OSPF 10. Let's put this one here and modify this. Add the route map. So route map, what route map here? Route map name is, what is our name? Name is RM1. Okay, RM1. Now we use this route map to limit it. Only one routes can be redistributed into the OSPF. Okay, here. Next. So here I can put the metric tab here. Just want to show you what's the metric tab. So metric tab, we can change metric tab from the default E2 or change the E1. Put the 1 E1. Okay. Now let's check if it work or not. So to check if it work or not, let's go to the AGG1 route, to the show IP route. Show IP route 30.0.4.0. Let's see. Yeah, first see look it seems to be works, right? So first see the metric type is E2 is already metric type is increased, right? So before it's 20 now 22. So type is E1. So since we changed E1, so metric type it becomes the external metric plus the internal metric, so metric something like that. So it seems to be work. Let's take a look. Did he block the another route 30.0.5.0 into the OSPF? Let's take a look. So 0.5, we should know this route into the OSPF because in our route map only allowed 30.0.4.0/24 into the OSPF. Yeah, perfect. This is no, not in subnet. So this route was not redistributed into the OSPF. Okay, here is use route map to redistribute OSPF. So you can redistribute the static into the OSPF. Also, you can redistribute the connected into the OSPF. Also, you can redistribute the ERGRP into the OSPF. You can redistribute BGP into the OSPF. In this video, we just quickly show you redistribute static routes into the OSPF. Yeah, I just also give a quick review to the route map, very simple route map. Okay, so this is all about this video. If you like this, please give it a thumb up. Don't forget to subscribe. Thank you so much.